Hello everyone, and thanks for coming to my second video in the series. Today we're gonna spend a little bit of time talking about the data science process. If you watched my previous video, we went over the process of setting up a Python environment for machine learning. So we created an environment that we can actually start to use and build machine learning models. But before jumping into the coding aspects of building models, I wanted to spend a little bit of time and walk you through the process of thinking about a problem in data science. Let's first think about what's data science and why is suddenly everyone interested in data science and machine learning. So in the real world, we have problems that we need to solve. And so you should think about data science as a way or a new approach to solving problems. So we have problems in science, we have problems in business, we have problems in so many different areas. These are real world problems that we need to solve. So let me start by creating a box for our problems. So these are real world problems that we want to solve. Now, if you think about a scientific process, the way you would make a discovery or you would come up with a great idea is you basically theorize, you hypothesize, you have some ideas based on your past experience or knowledge. And so you have hypotheses and everything starts with your hypothesis, everything starts with your theory, and then basically, if you're thinking about, let's say, a business context, you have some ideas or intuitions about what would be a good decision. And so you take actions based on your decisions, what you feel is a good decision, and you collect data once you take actions. And you basically look at your data and analyze your data to kind of validate your decisions, to see if the decisions you made were good decisions or maybe they were not quite good decisions. But the idea is that you come up with an idea based on your previous knowledge or your experience, and then you collect data. So the hypothesizing piece comes before the data collection piece. Now, what data science does, it kind of reverses the process. And the idea is, if you have data, you can look at that data and maybe the data has the theory hidden inside it. Maybe the insight you are looking for, the good decision you are looking for is hidden in the data. So instead of trying to theorize first or hypothesize first and then collect data to validate that hypothesis, you start with data. You have some data or you collect some data and then you look at the data and you apply algorithms to your data, and through these algorithms you try to learn something from that data. You extract an insight from that data, and this is something that you can act on, and hopefully this is going to help you make better decisions, become a better business maybe. And so once you have a problem, the next question becomes, what data do I have that would be relevant to this problem? So my next box is gonna be data. And you've already seen that problem and data are interconnected. So the problem you're trying to solve through data science is going to need some data, and your data dictates what kinds of problems you can solve. And so you have to go back and forth between understanding the problem, the business requirements, and the data that's available to you or the data that you can collect. And at some point you're going to decide that I understand what's the problem that I want to solve, and I think I have the right data to apply to this problem and try to solve this problem. Once you have these two pieces, the next piece is going to be pre-processing. So I'm gonna have a box for pre-processing. So the data that you have oftentimes is not initially collected for data science work. Data is generated as a byproduct of businesses, doing their day-to-day operations, and so you have some data that's sitting somewhere, and you're trying to look at it and see if you can extract some insights from it. And then, so what's going to happen is that the data might not be quite clean. You might need to do some cleaning on that data. There might be missing values or incorrect values. So you might change the format of the data. So there is some work that you have to do on that data before it becomes data that's usable by machine learning algorithms, before you can feed it into machine learning algorithms. And so you have to do some work in the pre-processing area. And once you have pre-processed data, that's when you can apply different algorithms to your data, and this is what we call modeling. And this is where you have to have a broad understanding of different types of machine learning models, and so you can look at a problem, you can look at your data, and you can decide this is the model that I'm gonna try. And so this is the modeling phase. At the end of the modeling phase, you have a working model, but then the next question is, how do I know if this model that I created is a good model? And so what you have to do is you have to evaluate your model. So you're going to have a evaluation phase. So you have to evaluate your model and kind of make sure that your model is performing at a level that's acceptable by the business that's going to use this model to make decisions if you're trying to solve a business problem. And so any problem is going to have its own different requirements in terms of performance. And so there is a set of metrics that you have to compute, and that's what you're going to use to objectively evaluate if a model is a good model for its intended purposes. And once you have the model and you've evaluated the model, now you've been through this cycle of data science, from understanding the problem to deciding what data you're going to use, to pre-processing that data, to modeling with that data and evaluating that data. And through this process, you've learned something. And so oftentimes this is an iterative process. What it means is that you have to circle back and go back to the original problem that you were trying to solve. Through this process, you have learned something. And maybe now you're thinking, I can go back and reframe my problem. If I reframe my problem, if I state my problem a little bit differently, maybe I can come up with a better solution to that problem. Or maybe you've learned you need more data or different type of data. Or maybe what you've learned is that if I did more pre-processing or a different type of processing, maybe my model would work better. Or maybe what you've learned is I should use a different type of model. But every cycle that you go through, there's going to be some learning, and you'll go back and circle back and do your second iteration and third iteration, and at some point you will have a model that's solving the problem, and that's where you're done. You stop the iterations, you have a model, and that's where you deliver your models to machine learning engineers, and they're going to take your model and deploy your model maybe in a web application, or it becomes part of an integrated solution, or depending on how you want to use your model, maybe you're done. That's you have a model that works, and what you are hoping to get out of this process is an answer to a business question, and now you have your answers, and those answers are the output of this process. And so people can go and act on what they learned from this process, the insight they extracted from this process. Um, so, so one thing I want to do in these videos is to give you enough of both uh, the conceptual and theoretic background, and also the hands-on practical aspects of model building and data science. Because oftentimes what I notice is that uh, people tend to focus on different aspects of data science. I've interviewed so many people for different data science positions, and I see people coming from different backgrounds, and they aspire to become data scientists. And some people have a stronger focus on the programming aspect, but they struggle with understanding the theory behind the scene, the concepts behind data science. Or I've seen people with a relatively good understanding of the concept, but struggling with the practical aspects of it. And so I think to become a good data scientist, you need both a good conceptual and theoretic understanding of data science process and concepts, the science of it, the science of data. But at the same time, you also need to have strong hands-on capabilities in terms of being able to translate your ideas into code that works, and you should be able to build your model. You should be able to build proof of concepts for your ideas and kind of demonstrate that your models are actually working and they're solving the problem. And so what I'm gonna do over the next videos, I'm gonna go back and forth between theory and hands-on exercises that we're gonna do, and we'll build some models together. And I'm hoping that this is gonna give you a path to becoming a data scientist. I'm hoping this is gonna help you with your journey in becoming a data scientist. Thanks for watching, and I hope to